Okay, now that I've organized the data into this table of how many of each number face that I rolled for each color of dice, I want to organize it in a way that it can tell me the percentages, because I rolled a different number of white dice and a different number of gray dice and a different number of blue dice. So having 4 out of the 14 dice coming up blue, what is that as a percentage? Was this the most likely result on this table? So the way I do that is I can copy the same titles down. So this is white, gray, and blue. And again, we have our number that was rolled. So this is 1, 2, 3, 4, 5, and 6. And our totals now. So our total should be 100%, right? Because whatever you roll, it's 100% likely that you'll roll something. So all of these down here should be 100%. Alright, so what was the percentage of rolling a white dice? So what I do is compare a ratio of the number that I rolled that was 1 versus the total number of white dice that I rolled. So that's a fraction, 0 out of 15. Well, that divides into 0, right? So this is going to be 0%. So that was an easy one that you could do in your head, because there were no white dice rolled. There's 0% of the dice are white. It could come up 1. Okay, the next category. So now it's going to be 0 out of 15. Now it's going to be 4 out of 15. So 4 out of 15, I need to use my calculator. Grab it. And you're not going to be able to see that. I'll use the computer calculator. So 4 divided by 15, oops, 15, is 0.266. So I multiply that by 100, so times 100 to get 26.6. Or I could move the decimal point over 2. It's the same thing. So I write down 26.6, 7%, 0.67. Okay, and then do I have any other 4s? No. So and then I have a 3. So 3 out of 15. I know that's going to be 20% because it's 1 out of 5. And 1 out of 5 is the same as 20 out of 100, but I'll just prove it to you. So 3 divided by 15. 0.2. Move the decimal place over 2, you get 20, or times 100. Right? So this is 20%. And then any other 3s would also be 3 over 15. So the number of 4s would be 20%. And the number of 6s would be 20%. Now the number of 5s was 2 out of 15. So 2 divided by 15. That is 2 divided by 15 is 0.133, which is 13.3. 13.33%. So if I add these up, it should be 100. So 20, 40, 60, and so 60 plus 26.67 plus 13.33, and you see that it does equal 100. Alright, and then that's how you would do each one of these. You would say, well, this is 2 out of 17, and this is 4 out of 17, and that's going to be those I could get from those two, and then this one will be 2 out of 17, 1 out of 17. Oops, I got off here. 2, 4, that should be another 4, then a 2, then a 1, and then a 4. So I would divide those, multiply by 100, and it would give me a percentage. So I'll just do a couple more. 2 divided by 17 times 100 is 11.2 and which would also be this one, and 1 out of 17 would be half that. But anyway, so that's how you go about doing it. The blue dice I would do out of 14, right? Because that is the total number of blue dice. So let me do a couple of those. 2 divided by 14 times 100 is 14.29%. And let's just show you that the total percent adds up. So this is going to be out of 300%. Right. And then that number, I could divide that out of 300 and then find the percentage of ones, the percentage of twos. Okay. So let's just do that. So 11.76 plus 14.29, 26.05, and that's going to be out of a total of 300%, so 26.05. So 8.6. So the total number of ones out of all the numbers, so out of all the dice, will be 8.6%, which is significantly less than the average, right? Because 1 out of 6 is your normal probability, and 1 out of 6 is 16.67%. So ones came up a lot less than the predictable average, right? So how much the probability would be 16.67%, but we got less ones than we expected from our experiment. So that's how you fill it out. I'll just pause the video and okay, we're back. So I went ahead and filled out all of these percentages and added up across, and then I took this out of 300 and found out what was the total percentage of ones, total percentage of twos, and you could see that the average being 16.7, so 6 was pretty much at the average, 5 a little below, 4 a little more below, and then 2 and 3 were above the average, and 1 was below the average. So that's the kind of thing that you can put together with these sorts of charts. And it just so happened that when I add them up, it was 100, which I expected, but sometimes when you do some rounding, you may be off by, it might be like 99.9 or 100.1, so don't worry about it too much if you're off just by a little bit. But go ahead and check your values out there, and that's how you put this all together. Now, how do I read this? What die would you say had the highest percentage? Well, that would be, let's see, 28.57. So even though I rolled 4 on a couple of different ones, this one had less probability that I would get a total of 4 because there was less dice being rolled. So this one had the highest occurrence, 28%. The lowest occurrence was, of course, 0. You know, I expected that I would probably roll at least 1 when rolling 15 white dice, and I didn't roll any ones. So that's some of the ways that you can interpret this data. Sorry, I missed it there. That's a 0% there. 0 ones out of doing 15 of them. Okay, so go ahead and do the exercises on the packet.